Okay. Thanks, Andy. Yep, this is Euclid, the next European Space Agency Space Telescope, as Andy said, subtitled Exploring the Dark Universe. Okay, I'll do that. So, what is Euclid? Euclid is a visible to near-infrared space telescope developed by the European Space Agency and the Euclid Consortium. Euclid is named after the Greek mathematician Euclid of Alexandria, who lived around 300 BC and reported to be the founder of the subject of geometry. As the density of matter and energy is linked to the geometry of the universe, the mission was named in his honor. That's where the name comes from.
All right.
And the way Euclid came about, previously there was two missions proposed under ESA's Cosmic Mission 2015 to 2025. The first one was Dune, the Dark Universe Explorer, and Space, the Spectroscopic All-Sky Cosmic Explorer.
They work so hard on these acronyms, don't they?
Yeah, exactly. Both missions proposed complementary techniques to measure the geometry of the universe, and after an assessment study phase, a combined mission resulted. Euclid was selected by ESA's Science Programme Committee for implementation in October 2011, and in June 2012 it was formally adopted. So that's how it came about.
Right.
So the mission is to explore the composition and evolution of the dark universe. The Space Telescope will create a great map of the large-scale structure of the universe across space and time by observing billions of galaxies out to 10 billion light years and across more than a third of the sky. Euclid will explore how the universe has expanded and how structure has formed over cosmic history, revealing more about the role of gravity and the nature of dark energy and dark matter. Okay, the construction, the Space Telescope was built by Thales Alenia Space in Italy. And Euclid is 4.5 meters long with a diameter of 3.1 meters and a mass of 2,160 kilograms. Okay, just a little bit of science, not a lot, because I don't fully understand it myself. So what is the dark universe? Well, scientists, apparently astronomers and scientists, think that we can only see 5% of the actual universe with the visible instruments, our eyes, and our other instruments in the electromagnetic spectrum. We can only see 5% of the universe. So 95% of the universe is unknown or dark, and that's where we get the commonly known sorry about that. Commonly known as dark matter and dark energy. That's where we get that from. Okay. So 5 minute mysteries Euclid will help solve. What is the structure and history of the cosmic web? What is the nature of dark matter? How has the expansion of the universe changed over time? What is the nature of dark energy? And is our understanding of gravity complete? Okay, Euclid, or more about Euclid itself. Euclid will be launched on the SpaceX Falcon 9 from Cape Canaveral Space Force Station, I believe on the 1st of July. And originally, Euclid was going to be launched on a Russian Soyuz rocket. But this was changed after the recent invasion of in Eastern Europe, and then Russia, that was cancelled for that particular flight. But this is now being taken up by SpaceX. There's two science instruments. the visible wavelength camera, or VIS, and the near infrared photometer and spectrometer called NISP. The Euclid Consortium has delivered to ESA the VIS and NISP instruments, and NASA provided the near infrared detectors of NISP. Okay, Euclid will observe a third of the sky. It will measure the shape, position, and distance of galaxies out to 10 billion light years. It will create the largest, most accurate 3D map of the universe ever produced. Okay, so Euclid will address two core themes of the ESA's Cosmic Vision 2015-2025. What are the fundamental physical laws of the universe? How did the universe originate, and what is it made of? Okay.
Yeah, but are they going to explore anything important?
Don't
Those are small questions, you know. Get real.
Yeah.
Okay.
Right.
So Euclid isn't a large telescope, but as space telescopes go, it's a 1.2 meter diameter mirror, and the spacecraft itself is only 4.7 meters tall and 3.7 meters in diameter. I think, as you can see from the previous slide, it's the actual instruments that are doing the work, of course, and that's where we're going to get the science data from.
So the actual mirror is only 1.2 meters.
1.2 meters, yeah.
Yeah.
So the visible instruments measures the shapes of billions of galaxies between 550 and 900 nanometers wavelength. It has a mosaic. This is what interests me. It has a mosaic of 36 CCDs, or charge coupled devices, each one giving 4,000 pixels each. So each CCD has 4,000 pixels on that particular detector. The near-infrared spectrometer and photometer measures the brightness and intensity of light from the galaxies, and is used to calculate the redshift stroke distance. And that works at between 900 and 2,000 nanometers wavelength. And that detector has a mosaic of 16 detectors, each having 2,000 by 2,000 pixels each. That will be the largest infrared field of view from space. I haven't actually checked that against James Webb.
It's a lot wider field than James Webb.
Yeah.
Yeah, it's a lot wider.
So that still stands.
Yeah.
Good. Okay. So Euclid will be stationed at Lagrange point 2, and it will actually be in the same orbit as the James Webb Space Telescope and ESA's Gaia Space Telescope. Launch, as I said, will be on the beginning of July. Excuse me, and it takes about 4 weeks to actually get to L2, much like the James Webb did.
Right. So they're going to be neighbours.
They are going to be neighbours. So just like the James Webb Telescope, Euclid has a large sun shield because obviously it wants to look in the opposite direction to the sun and the Earth. So this is just a slide showing the number of countries involved in Europe. So the list of countries there, obviously Germany, Italy, Spain, Portugal, and of course United Kingdom. So we're providing quite a lot of the expertise for the mission. Beyond Europe, we have the United States. NASA is providing some of the detectors, instruments for the spacecraft. and of course SpaceX are providing the launch.
I love the involvement of Spain in this.
Okay.
If you look at all the other countries, it's space this, space that, space this. And in Spain, it's the Ministry of Economy and
Competitiveness. I thought that was good. Yeah.
So, because I don't think there isn't a national space agency in Spain.
Okay.
So there we are.
To create one.
Yeah, got to be competitive with these dark energy surveys, haven't we?
Yeah. Okay. Now this picture here just shows the size of the spacecraft.
What a beauty! What a beauty! Look at that.
Yeah, I know. This is actually an engineering test model, which will stay on the ground. It seems a shame to build something like this and not send it into space to me, but
perhaps it'll end up in a museum somewhere.
Yeah, hopefully. So you can see the size of the spacecraft compared with the people, the technicians working on it on the floor.
He's having his lunch.
Yeah. Now you might recognise this ship. This ship carried Euclid from Italy to Florida in the MN Colibri. It's also carried the James Webb Space Telescope from Europe and to South America to Kourou for its launch. It's done a lot of work for space program recently. And that is how it was transported in that big container, and that is at Cape Canaveral Space Force Station. Okay, as I said, it will launch on Saturday, the 1st of July at 4 p.m. our time, which is a nice time of Saturday, so we may be able to have a live launch for that. And just so for those that may not be familiar, it will be launched from Space Complex 40, which is to the south of the Kennedy Space Center on the Space Coast. Right at the bottom of the slide here, you have the Space Launch Complex 40. 41 is there. The Launch Complex 39. With Launch Complex 39A, which SpaceX use for their crewed launches, and their rocket launch, their rocket assembly facility is near there on the old crawlerway. And just at the top of the slide, you can see Launch Complex 39B, which is where future space launch systems will launch from.
Great.
And just a minor one, this is the route that the rocket will take to take it into orbit before heading off to L2. And as you can see, a little blip out in the Atlantic Ocean, that is where the drone ship is that will catch the booster for landing. Okay, and if you want to know more, there's a website there. You can put this in the chat if you like, but there's plenty on the ESA website about the mission. If you want to, if you want to find out more.